Welcome, everybody, to the Distilled Buildings Tech Podcast.
Where smart buildings are shaken, stirred, and data-driven.
Awesome. So I'm your host, Jason Shearer.
I'm your host, AK.
And we are here with Ronna Davis. Ronna, you want to introduce yourself real quick?
Hey guys. Ronna Davis. I'm Chief Revenue Officer at VoltServer.
Excellent. So one tradition with our podcast is, with the Distilled Buildings Tech Podcast, flair is to have a cocktail every time. And we generally try to cater to our guests. And Ronna, tell us a little bit about the cocktail that is your favorite and that you are that you're bringing to us today.
Yeah. So my drink, and I slightly modified it today, but my standard drink is a vodka and soda, typically Kettle One would be my favorite vodka, with 3 limes, and I'm very specific about the 3 limes. That's how much you need. Yeah. And but today I've modified it with lemons from my own tree, so I'm doing a lemon variation of it today. And I drink it because I do a lot of you go to a lot of work events, a lot of social events. I can slow sip it. Yep. That's one of the reasons I like it. It's refreshing. It's enough to keep me hydrated, but it's not so delicious that
you're slamming them.
I'm slamming them, right? That's really why I drink it.
Yeah. Well, and I can appreciate like the summer refresher type drink. You're outside. Whether you're by the pool or you just got some yard work done. Like, there's nothing better than a vodka soda or a gin and tonic to kind of take the summer heat off.
Absolutely. Yeah, absolutely. Definitely a by the pool drink.
Yeah. Very cool. So tell us a little bit about your, we'll definitely get into VoltServer and Fault Managed Power, but tell us a little bit about your career journey. Like, you did not start in Fault Managed Power.
Yeah. No, I did not. I did not. Fault Managed Power is relatively new. I've been in the game for a while. So, almost right out of high school, I ended up working for a small company that sold PBXs, business telephone systems. And so I kind of started on the voice side. It was mid-90s, so it was right when network infrastructure, everything was moving over to Ethernet from, token ring systems and IBM Type 1 and Type 2 systems. And so there was a ton of growth in the area, but started in basically PBX systems for businesses that migrated into things like voice over IP, network cabling infrastructure. So I kind of moved on to a larger contractor that did large scale network infrastructure, and sort of found that was what I really liked. They did all special systems, but for some reason, I love the infrastructure part of it. And so I was in that portion of the industry delivering or installing special systems for about 8 years. And then I moved to wholesale distribution for a couple years. And then I went on to work for CommScope, a manufacturer of network infrastructure. And I was there for almost 18 years, held different roles when I was in the contracting, did everything from, sales to service manager on that side of it. And then when I moved over to CommScope was in sales, then moved to our global partner organization, worked on ecosystems, and then strategy and technology before I left. And then I moved on to VoltServer. I've been with VoltServer since the end of 2023. I've been fortunate enough throughout my career to work with great people, have great mentors, and really, I love tech. I do. I think one of the drivers for me has always been how it improves our lives, and that being a part of technology early on, where PoE was just, talking about like voice over IP, right? And part of that happening. And I remember it feeling so hard at first, like, we're not going to convince people, even though this really makes sense. Yeah. And, but then it just once the train left the station, man, it just really moved. And that's so exciting to see. And I don't know very many other markets. Maybe healthcare might be like that, but technology is a place where you really get to see an impact from your work. And I love that.
Yeah, I always joke around. I always joke around like how many IDFs do you walk into where there's an option 11 or a PBX these days, and it's like 0.
Yeah,
None.
no, it's not a thing. Yeah. And it's not that long ago that it was really, that was the standard, that you'd see 66 blocks, 110s, and that'll, the Meridian option 11, or maybe one of the big AT&T or NEC systems. Yeah, absolutely.
And you made a big change from infrastructure, which, a lot of us would think of as passive, and then to an active component, which is FMP. How did that affect Rona and opportunity and obstacles? Did that bring any of it forward to you?
Well, I never consider myself like the expert in the room. I like to be in a room full of experts. And at CommScope, it was always like that, right? I mean, it's really sharp people. And so I was learning every meeting I go into. And then at VoltServer, wow, I mean, it's the technology is so advanced. It's a lot to take in technically for me. But I think that while it is the active components, it still is infrastructure. It really still is the infrastructure piece. It's, and for me, how I even got to VoltServer is interesting because at CommScope, we were working on the development of a solution that was a fiber to the edge deployment, because I'm a firm believer that we need to get there. We've got to get fiber to the user edge in buildings and campuses because the bandwidth demands are just going to be there. And if the bandwidth demands are going to be there, the power demands are going to be there. And so we were working on the development of a solution at CommScope. It's launched. It's called Constellation. And that's really where I got to work with the VoltServer team. And I just knew that this technology was important. I knew that it was going to be really important. I sort of have a tag. This is a Rona-ism. Safe power changes everything. And I believe it. It really does. And so I had an opportunity to make the move. And going from a big, huge organization, I think CommScope had like 30,000 employees, down to a much smaller organization, but with a technology that I think really does have the potential to change everything.
And maybe tell the audience what's the definition of FMP from Rona's perspective, because they're going to hear Mahmoud's and I want to hear from you. What's FMP? What does it stand for? What does it do?
Yeah, so FMP, fault managed power. That's, and then, really by definition, it is a connected power system that is able to monitor a circuit for faults and limit the amount of energy into a fault on that circuit. And what does that mean? Well, that means that it's safe for people to interact with. It means that it doesn't start fires. And so what that, my moniker, safe power changes everything. Well, now if power is safe for people to interact with and it doesn't start fires, that changes where we can install power, how power can be installed, and who can install it and work with it. And when you look at energy, and energy being one of the main constraints for economies, right? Like the ability for an economy to grow, that access to energy, that's that constraint, right? How hard it is to build these big, to build power, to get power distribution, power generation, and then to get power distribution to where people can use that power. If we can make that easier, fault managed power can make that easier, then I see that it really does have the potential to release trillions of dollars of value throughout the world. And so I guess that's what it is to me. It's power that is safe for people to interact with. It's significant power. I think that's an important piece to make too, because you talk about PoE, and PoE is also a great connected, safe technology, but it has power limitations, has some distance limitations, right? Where fault managed power is significant power, and it can go pretty significant distances as well.
Yeah, a couple of weeks ago, people will have heard from Andrew and Andrew Liu. Like, you've probably heard him talk about, his DC donut of viability. Where at the megawatt level, it might be like ArcSafe DC, and then FMP, and then PoE, and like each one of those kind of like layers of the onion, like has its own economics. What I would like to hear, like you said, the where, the who, and the how. But first, do you think, like, having gone through big technology transitions like TDM to voice over IP, does this feel the same, like, as far as the opportunity?
It feels bigger.
Yeah.
It feels like the song in the back of my head, Jason, is I feel the earth move under my feet.
Yes.
That's it. Like it's bigger because and I love data. I love data systems. But for all data systems, you need power too. So, and this is obviously it's beyond data, right? What we can power, it isn't just powering data systems, although almost everything's you're going to want data from pretty much everything we already do. But I feel like it's bigger.
Got it. And the two inflection points I see are, we're still in this real estate reconfiguration, rationalization inflection point. And then on the other side of that push and pull, we have AI, right? And like AI is going to be super power hungry. Like, how do you see both of those like playing into the demand for FMP?
Yeah, I think that as this office space gets reworked, and I think some of it that's happening now, right? That the utility of fault managed power to be it's more modular. It can be deployed faster. It's intelligent, right? It's going to make reworking the spaces easier. One. And then I think as we're reworking these spaces, I'd like to see more fiber to the edge so that we're able to support AI and and so, virtual reality, augmented reality, AI, those analytics. I think we're probably likely going to need some compute at that very edge, more devices with compute built into them. That means there's going to be more power demand out there, but we're still going to want to send a lot of data back onto the network, which is why I think that we're going to need fiber for it. And so I think as spaces are reimagined, that fault managed power will be a great tool to enable those technologies that are going to really transform the buildings and the workspaces, I think, pretty significantly over the next 10 years.
And what industries, or at least type of projects, do you think that are most relevant for FMP today? I mean, we know it's already been deployed. And what others that are lagging still that needs to catch up, or maybe not ready for FMP today?
Yeah, so VoltServer has over 1,000 installations. I think we're approaching about 50,000 circuits out there powered with fault managed power. So, but there are areas where it's easier, where the transition or the movement towards fault managed power is easier, and some of the early on, we've seen a lot of success within telecommunications networks or powering cellular antennas, basically. DAS,
like inside of like big stadiums and facilities, right?
Yep, that's right. Yeah. Those antennas that require more power than what's available for PoE, or they're really, really long distances because of the type of building that we're working in. So I think that the areas where the most immediate value is seen is in those environments that have long horizontal spans. So distribution facilities, big box retail, manufacturing, very strong use cases for fault managed power. Now, in a lot of those spaces right now, they're all undergoing through a retool, right? This Industry 4.0, and they're introducing a lot more automation and robotics, and all of those things are going to require more power. They're also going to create more diverse workspaces, or workspaces that they're going to want to be able to reconfigure. And that will bring a lot of value, I think, to those facilities. So I think that's one of the areas where the use case is very, very strong, because they have long horizontal distances. They do need significant power, and automation, things like robotics, AI, and augmented reality solutions are prevalent. And then beyond that, I really do think that the office space, because of the rework, as the office space is being reworked, universities and education is really going to be able to take advantage of AI and virtual reality technologies. So getting fiber and more power into the classrooms, I think, is important. And then looking out just a little further is data centers. And when I say a little further, I don't mean really far out. I mean in a couple years, that we've gotten to the point where the technology can support significant power, that where we can play in a data center space, and even being able to power hundreds of kilowatts in a rack. A lot of the reason why for fault managed power, it isn't that much of a reach for us, is because we don't have all of those safety encumbrances that you have to put around electrical that take up a lot of space. They do. And space, obviously, within the data center is the highest value. And so if they're going to have this level of compute, they need, in this small of a format, you need power that can be in a smaller format. And fault managed power does that. So when I look at what's coming out there, and I call it my North Star, which is getting fault managed power directly into power supplies in the servers, where at that point, it's something about the size of an RJ45 that plugs into the back of a server and is delivering, kilowatts of power, and can be deployed like a structured cabling system. I gotta go back to my structured cabling roots. I can't help it, because it is so important. Infrastructure is so important, because it offers flexibility, right? And now with this small form factor power that's high density, that can be delivered in a pre-terminated format that's modular. I mean, the value proposition there is, in my view, it's the value proposition is probably the best, but we're a couple of years, but it's there. It's very real and very exciting.
I do agree with you, Rona, because I think when you said that the opportunity is bigger, this has not been done in the past. Hundreds of years, we've been delivering power the same exact way to the edge. And today, what you just said, there is an opportunity for an infrastructure or an RJ45 looking cable that delivers kilowatts worth of power. This has not been done before. This is new cutting edge technology that's going to change the way we build and deliver power forever. I think it's, and then, you look way down, down the line further. But I think about how AI, it's digital power, right? And now let's put some AI on it. And what does that do? How much smarter does the system get? How much more efficiency can we build in? And I think that there's just so much potential. But I would kind of say in that order. Look, that warehouse distribution, manufacturing, big box retail, long horizontal spans. I don't particularly like that term, low hanging fruit, but I'm going to use it. That's kind of low hanging fruit. It's very obvious, the value proposition, and they're already so akin to DC technologies in those spaces anyway. They prefer it. And then I think the rework of our buildings and campuses, I think, is a great opportunity. And then data centers. In terms of value, that's where power density is, right? So,
So that and that North Star being right to the power supply. Because right now, the way that the systems work is you have a transmitter and you have a receiver connected by a cabling. That receiver takes the fault managed power in and then converts it to a traditional power type. So it converts it to 48 volt DC, 56 volt DC, AC power, or high voltage DC. And then you use that connection into a traditional device. When we look at the data center, think about that power supply now. Instead of having to do a AC or a high voltage DC plug, which is quite large, right? And everything to make it safe so people can work with it, quite large. Now all of a sudden, it's just fault managed power directly into that power supply. I mean, just like your NIC card, just like plugging into your NIC card, guys, just like that
And you think about this, like the safety component of it, because these data center racks, like traditionally we've thought about, 8 kilowatts in a rack being a lot, but now we're going to 50, 140, and NVIDIA's projection, like in 3 years, is like 600 kilowatts in a single rack. And so now, in order to achieve that, we're going to have to start doing either on-die or immersion cooling. And that just raises the bar on like electrical safety. So it's almost like we have to have some sort of a new technology to ensure data center, dorky little data center engineers aren't getting electrocuted.
No, you're right. We're introducing liquid in places we've been trying really hard to make sure
keep
liquid
water out.
So there's the safety element. There's the space element too, because now you have to have plumbing systems that you have to account for. There's a whole building subsystem now that we have to pipe to the rack. And so I completely agree. And a couple of years ago, Steve did a demonstration. Steve Eves, Steve Eves is the inventor of fault managed power, and he's our CEO. And a couple of years ago at DCD, he did a demonstration with fault managed power in a fish tank. Right. And I think he was trying to get the point across. Look, we heard you guys are going to put water in your data centers. Let's talk about it. And so I think it's a great point that you bring up, Jason. We've got water in the data center now. So,
Rona, you talked about some limitations of PoE, and we hear this from the audience and a lot of comments. Is FMP are going to change or replace PoE?
No, man, it enables it. It enables PoE. Look, there's most devices in the building require less than 100 watts of power. Why would you not use PoE? It's a smart technology, right? You're able to capture data. You're able to cycle power remotely on those devices. The cost models for PoE are great. There's plenty of electronics that are available now on the market if you want to embed PoE as a technology into your endpoint device. So I see fault managed power as a way to make it easier to deploy PoE. Now, I would just say, so some people say FMP is the backhaul to PoE. And I agree that it is, but I also think there's other things in the building that we're going to power with FMP that exceed the power, the power capability of PoE. So I actually see it as a great enabler as to be able to deploy more PoE to edge devices.
And for our audience that are probably not living in buildings and want to see this technology in their home, when do you think FMP would actually make it to the consumer level, if it ever will?
Yeah, I do think it will, because if you've noticed the thing about at least we'll talk about the US, right? Because I'm only dangerously oriented to any other building codes outside of the US, but the code has been progressively more safe, especially as it pertains to residential consumers. And I think that's the direction it should go. That should absolutely be their directive. And so while the inclusion of fault managed power for the 2023 NEC didn't include residential, I believe it is in the 2026 going to be included. The the use of fault managed power in residential and making power safe for the residential consumer, I see as it's a no-brainer. It'll happen. The biggest obstacle with getting there, getting to that point, is really the technology being embedded into endpoint devices, right? So, where and what is that distribution going to look like? Is it going to mean more PoE to outlets, powering more things, and then the FMP powers the PoE? Is it going to be that we've got FMP circuits that now go to different appliances and devices, and then those devices have FMP embedded inside of them? But you have to have interoperability. You've got to have some things before that can really be real into that market. But I absolutely think the value is there. They're doing all kinds of things to reduce fire risk in buildings right now. In the jurisdiction that I live in Henderson, Nevada, new single-family residential has to have a sprinkler system inside of it. Yeah.
Inside.
Which,
oh, wow.
like a fire sprinklers in a single-family residential, there may be a square footage, distance, but I know that it affects like a mid-sized single-family residential home, where historically you've only needed that in multi-tenant. Well, so things like fault managed power are going to reduce the risk of fire. That's going to be better for insurance premiums. It's going to be better for the health and safety of the occupants of those buildings as well. So I see it as a no-brainer, but I do think that there's steps along the way from an adoption standpoint to get there.
And it's a disruptive technology, right? Like, it's very different than how we've designed and built, buildings and homes and conferences and trade centers for the past 150 years. And now I think this publishes on June 30th. So we will have had Cisco's big Cisco Live in San Diego a couple of weeks ago. And in planning for that, all the trades were like, whoa, can't bring this in here. We had some manufacturing robots on the show floor that were 48 volt powered, like some FANUC robots. And we're like, yeah, you can just power those off of a FMP receiver. They're like, no, we can't. We're like, well, 48 volts is 48 volts, right?
Yeah.
Like, there's no difference.
Yes,
so a lot of this is just overcoming, fear of new technology.
Yeah. And I think, when you think about the electrical industry, where it's different than, you get something new on your iPhone and, that's great. But a lot of the electrical industry is built on safety, right? So you have a group of people who their responsibility was to make sure people did not get electrocuted, buildings did not burn down, right? And so I respect the pushback, that they want to learn and they want to understand and they want to make the right decision. And I respect that. That's why they're there, right? But technology is safe. It is safe, guys. And it's going to, it is going to change things. And the ecosystem is not, they're not adverse to the change, I wouldn't say. Overall, there's a lot of interest and a lot of support in moving things forward. But it certainly is a rock that we're pushing, right? It doesn't move fast because I think because of the safety element of it, and because of the people within that industry, their careers is built on the safety and security of building occupants and assets. So I do see it as, I don't see them as like really holding it back so much as help us understand, right? Yeah.
A lot of education.
They're doing due diligence. And I think, Rona, from your perspective, VoltServer and others are doing some of that to educate the market. Why don't you tell us some of the initiatives that you guys are doing on the FMP side to make sure that you spread the message, right? It can't be one company. I think there's a whole alliance that actually moves the standards and the mission forward. So that way people that are sitting back and looking at this can understand what they're expecting and what does FMP mean for the industry.
Yeah. So we're one of the founding members of the FMP Alliance. So a group of stakeholders, VoltServer, Cisco, Pandit, Prismium, Belden. We formed the FMP Alliance, and now it's grown. There's additional members since then, with the core mission of educating the market and moving towards more standardization and interoperability. Now, we're not a standards group, but as a collective, we can help to move those things forward within the standards bodies and the code making groups. And so we see that within the FMP Alliance. It's a relatively new alliance, but we're getting our feet underneath us and working with other industry trade groups that are supportive, so we can bring, kind of that whole message to the market. And then VoltServer, we do a lot of work with NECA and the Electrical Training Alliance, the JATCs, because it's important that people know what the technology is. They understand what are the installation requirements. And so we do a lot of that work. We also are doing work even with universities, right? And talking to their groups there, because you've got to start to incorporate this understanding and this knowledge base into the training programs for these electrical engineers, right? So there's work that has to be done there as well. And then we work with organizations like Bixie on getting training and getting in front of audiences to teach them about the benefits of it, but also just the general understanding of how these systems work and how they need to be installed and managed.
Yeah, I think that's a novel approach that we're all taking, of like coming from both sides of the problem, from the low voltage side, from Bixie. I know you and I got to spend some time together in January in Orlando, and then a little teaser for a future episode. We have Jeff from NECA coming on in a couple of weeks to talk about how he's trying to approach it from a certified electrician, like high voltage electrician side. So it definitely takes a village to get everybody enabled on new technologies and standards.
Yeah, definitely a lot of interest though from all of the different industry associations or trade groups. The interest is there, and I applaud them for that. They're proactive in coming to us and asking us for the information, help us get trained, so that we've got the labor force that customers want to use to deploy managed power. So
that's I was at a consultant forum with another FMP vendor in Chicago a month or so ago, with MEP firms, cabling contractors. And I think that they're even still trying to figure out, like, is that something that the comm side specs out and works on, or is that something that like the traditional electrician side works out? How have you seen that actually going down in projects?
So I think it's going to go in phases. And I actually believe it's going to be shared. Ultimately, I believe it's going to be shared based on the application. And if you are designing data systems, right? So I like the current orientation of the technology. Like right now, today, I would say we power networks. Really, think about it. Networks, we power networks and some building subsystems. That's what we power. And so I think that as long as within the space of powering networks, I think a lot of that's going to be done by through the low voltage design, right? Now, each state's going to make up and decide how they categorize things and whose stamp needs to be on it and who pulls the permit. But generally speaking, I think it's probably going to be in low voltage design as long as we're powering networks. As we move beyond that and we're powering mechanical units, like we've powered a train air conditioning unit and some split systems, or powering some stoves and doing things like that. Well, then I think that is squarely on the more traditional electrical side. So I think it's going to evolve to include both. I think in the short run, most of what we're doing today is powering networks. So that makes sense. Data center, we're going to be working with the electrical engineers.
Yep. Cool.
If I'm designing an FMP project, or I want to learn about VoltServer, where do I go? Where do I find information about VoltServer and Rona?
Yeah, well, so you can go to VoltServer.com. That is our website. And then please reach out to me on LinkedIn and on my LinkedIn page. Would love to connect with anyone that's interested in fault managed power. Also, if you're a company out there and you would like to learn more about fault managed power generally, you believe your company may have a product, you're either developing products or supportive products, join the FMP Alliance, right? Because that's fmpalliance.org. Because we're starting to do some great work in that we need more manufacturers, we need more engineers involved there, and we actually want end users there as well, because we think it may be very helpful to have a user group talking about the different ways that they're deploying fault managed power. Having a peer group within the FMP Alliance of users, we think may be very helpful for people that are considering fault managed power for their organizations.
Yeah, cool. And then we spent some time in Savannah together at Realcomm. But where else will VoltServer be showing up, like throughout the summer and like into the fall, from a conference and a trade standpoint?
Yeah, so we will be presenting at NECA. Potentially at Bixie. I think we're all sort of waiting to hear back on the final plan for Bixie. But next week, actually, I have a Bixie webinar that I'm conducting on April 30th. And it's on really the market opportunity for fault managed power. Like, it's kind of some of this, but, less cocktail and more slides.
Yeah.
But
NECA will be interesting this year too, because it's in Chicago, and we all know that like Chicago is a very I think somebody at Cisco said the other day, the U.S. has a fetish with conduit. Like Chicago has a serious fetish with conduit. So
they like their conduit.
Yeah, they like their conduit. Yeah. So it'd be cool to have the NECA conference up there, where it's an even more difficult market to disrupt.
Yeah. No, I'm looking forward to it. I think Steve and I will be at the NECA event.
Awesome.
That's awesome. As usual, for the audience, like and subscribe. Follow us on all social media. But I think, Rona, it's a pleasure to have you. It's always great to see you. Thanks for the recipe. Definitely a great cocktail.
Yeah. All right. I appreciate it. Thank you, guys.
Cheers.
It was great chat.
Yeah. See you guys.
Cheers.